All right, let's talk about web development. Right. So what we mean by web development is that we're going to be applying software engineering principles that you might be already familiar with in other contexts, but applied to the web. Right. So using the web as a an infrastructure, programming infrastructure, right? That has its own idiosyncrasies, right? That it's based on a client server architecture of exchanging data between multiple different tiers in the application, and all using the web as the infrastructure. But indeed, it's a using the same exact principle that you would use in other environments. So first of all, we'll start with some of the basics. Right? What's the internet? Um, so basically, it's just one huge global network that was part of research in the 60s when at the end of World War II, folks were asking, how do we win World War II? And said, well, we bummed the heck out of these guys, right? And what would happen if that happened to us? It says, how could we possibly survive something like that, right? And says, well, let's see if we can create all sorts of huge redundant network that doesn't matter how bad you bomb it. There'll always be enough redundancy in the system that you can still communicate, right? So anyway, that was perhaps the idea to survive World War III. But since then, it has completely changed its point of view. Right now, it's more of an entertainment network. It was opened in the 90s for commercial use, and when they were when we were deciding to whether open it up for commercial use or not, he says, what could you possibly want to do commercially on the internet? Folks had no idea what this could eventually become. Uh, and obviously, the rest is history. What is the web? So, web is the just a one particular use of the internet, right? Somebody thought of a great idea. Says, well, you have all these distributed pieces of information out there, all these documents, and each document has its own viewer. It's differently formatted. How about if we could possibly agree on a particular format, and we can simplify the way that we retrieve all these pieces of content and have just one viewer that can view all these things, right? And then plus, how about all these documents somehow could relate to one another and refer to one another, and you could navigate very easily between these two instead of having to bring up FTP or all these different viewers to retrieve data and then open it up with a different viewer. Can we agree on that? So Tim Berners-Lee uh, in '89, working as a physicist in CERN, he came up with this idea, and he used XML as a standard for being able to encode or format the documents that he wanted to share. It was mostly research papers, physics research paper that he wanted to share with some folks, but certainly it just exploded, and folks found many different other ways of using it. And basically, you have a browser. He wrote one of the first browser for fetching these HTML documents over the network, downloading it, copying it into a local machine, and then rendering it and on the browser. Uses URLs, uniform resource locators, to identify and find these documents, copies them into local cache, and then renders them for you. Some of the text you can format it as headers and paragraphs and whatnot. But some of them you can format it so that they're links, right? They reference other documents. That when you click on them, right, it allows you to navigate to other places. Some of the milestones, the internet, the client server architecture, splitting the idea of who is the owner of the or centralized storage of all the content, all these files, and then you have clients that you only ask for subsets of the documents that they need. We still use the same architecture, developed in the '70s. Uh, we there was a shift from these centralized big computers that everybody shared with dumb terminals, and then we kind of switched over in the '80s when we had personal computers where everybody had their own computer on their desktop, and kind of broke a little bit that model of having this big centralized computer, and these PCs were powerful enough to run all sorts of software on our machines. Today is kind of where we're going backwards, where we left off in the 70s, where we have a browser, this dumb terminal that goes to a server, retrieves this data, and then renders them back on the front end, right? So we see these kinds of waves, going back and forth, finding it's where to settle. The World Wide Web, exploding in the 90s, and lots and lots of technologies that were developed, right before the dot-com bust. Tons and tons of startups, trying to reinvent the future. A lot of that technology survived the dot-com bust, and today, it has become fairly the bread and butter of building web applications, right? Where folks were finding that the web wasn't just a means of displaying content for consuming content, but it was actually a framework that we can use to actually build full-fledged applications. Folks started demanding more from web applications. They became complacent and said, well, I can do this on my desktop. Why can't I do it on a web page? And folks were happily to oblige, and we started creating all sorts of tools and libraries, and we started borrowing a lot of the best practices that were developed in the 90s on server applications, from Java and .NET and whatnot. All the design patterns that were created on the server side started finding their way into web applications and to implement fairly complex user interfaces. And that's where you get your Dojos, your Angulars, your React, right? It's a lot of those best practices and design patterns made their way onto client-side computing. Mobile computing, is also shifting what kind of application we're building today. That are consumable in small screens, and who knows where we're going, right? Maybe Neuralink, hooked up to our brains. Some frameworks that are of interest. Early on in the early 90s, the ability of being able to execute code that was running on some other server, right? So we wanted to be able to somehow, as a URL, refer to code that was executing in some remote server, right? And the Common Gateway Interface was the first example of that, and Perl, C++ allow you to create these small scripts that run in the server, but I can invoke from a browser. PHP built on that same idea. Java 2 Enterprise Edition was the first attempt at identifying best practices and providing some template on how web applications should be built, but was heavily based on a server-side web application implementation. Today, most of the well, not most, but a lot of that what we learned in the early 2000s has migrated towards the front end development. So we have somewhat abandoned this strategy that became very popular in the early 2000s, but today is mostly client-side rendering. So we'll talk about that. .NET as well, competing with Java, also a lot of best practices of their own. Ruby on Rails, Django, Node.js, right? We see that in the early 2000s, we see that JavaScript starts becoming more than just little animations and form validation. We see that it's starting to be heavily used to build full-fledged applications on the browser. And if you ever programmed in JavaScript, it's very, very challenging. So a lot of efforts have been to create the new to copy a lot of the what we've learned in strongly typed languages, and components and modulars, and a lot of inversion of control, all those best practices that became very, very popular on the Java side, .NET. See how we can bring that now into JavaScript so that we can build full-fledged enterprise applications. And not only and release JavaScript from the browser and allow it to be executable also on server side and on our own desktop. So Node.js is one of those efforts that allows us to execute JavaScript on the server. Python, client frameworks. Again, as we were demanding more and more from our web applications, they were a little clunky. They were, every time you navigated from one page to the other, it was a full refresh of the entire application. It was a jarring experience, right? As opposed to what we were comfortable with in our desktop application. Everything was smooth, and it was, I can drag things around. It was very responsive to me, right? Because I was the only one using it. These web applications, you were thousands of folks using the same web application, so it had to be rewritten, in such a way that it allowed it to interact with, thousands of folks at the same time. But as we demanded more from our web applications, there were a lot of efforts. Certainly, the JavaScript was the first effort, but Adobe Flash became very, very popular at creating rich clients. There were attempts at trying to achieve the same thing using plain old JavaScript. Dojo, jQuery, try to address the fact that there was a war going on the browser, the browser wars, right? Every big vendor had its own version of the browser, its own version of JavaScript, its own version of HTML. It just became a mess, right? So anybody who was implementing anything on the web found it very fractured, right? It was very, very hard to target all these different versions of browsers, or different versions of JavaScript, different versions of HTML. jQuery tried to address those issues, right? Of creating, it was the first attempt of creating a virtual version, right? Virtual browser, abstracting the layer of the underlying browsers and providing a consistent API that allow you to build complex applications. Other efforts such as Knockout, Angular was Google's attempt at introducing component-based applications, web applications, and creating modular, large applications in version of control, controllers, services. A lot of the best practices that became very popular on the server side, now you had a client-side version of that on the browser. Angular made a strategic error to going from version 1 to version 2. And a lot of other that gave way, opened up the possibility for other competitors to enter into that scene. So you have Backbone, Ember, Sales, Meteor that have tried to take advantage of Google's I think fatal decision to make version 2 of Angular not compatible with version 1. And that gave leeway to many other vendors to get in there. Certainly, Facebook's React is the one who has taken most advantage of that opening, and today is the most, I think, one of the more popular frameworks for implementing front end. We also see a lot of Vue becoming very, very popular as well. So those three are going to be covered in this class: React, Vue, and Angular. Some of the architecture that we're going to be using throughout the semester on the client side, meaning your browser. It's going to be, oftentimes I'm going to be referring to as the client, right, or our client application, right. That's what I mean by that is a combination of technologies that are being compiled or interpreted or rendered or executing on the browser. Usually the browser will be the client, but there's many other clients, right? It could be a game, it could be a desktop app, right? But we're going to be focusing on the browser being our client, right? And this code is going to be executing here on the client side. Obviously, going to have to go out to a server to download all that content, right? And once it downloads to the client, then it executes here on the browser. Usually, the communication is through HTTP. Where you generate a request and the server through any number of technologies, either PHP or Java or .NET, Python, whatever, is going to respond with some content, right? Whether you ask for an HTML document or CSS or JavaScript, it responds back to you and then it's executed on the browser. On the server, there's certainly many different types of servers, but we're going to stick to Node.js and a Java server, right? So Java server and a JavaScript server, which is Node.js. And these servers were oftentimes going to refer to as the middle tier, right? So the front end, the middle tier, okay, and in here you have the various resources, the actual file system to retrieve the different content, and also the databases, whether it's a MySQL or NoSQL. We'll focus on MySQL and Mongo as for our databases. But this is fairly much the architecture of what we're going to be building this semester. Now a little bit of history lessons here. In the early 2000s, most web applications were built using this approach, where the user would ask for a web page, right, to the browser. The browser would go out to the server, and in dynamic web applications, it would ask for any number of these technologies, either Python or JSPs or ASPs, PHP, all sorts of server-side solutions for building web applications. The server would fetch these files here on the server side, would compile them and run them, execute them here on the server. They would execute on the server, and what would come back to the browser would be static HTML. Right? So as far as the browser is concerned, it asked for some static content, even though it was dynamic and ran on the browser. Okay, and this is what dominated the scene for a decade or so of web development. Okay, a lot of techniques were developed during this decade, right? And modular and inversion of control, a lot of design patterns, data access objects, all those design patterns are still valid, right? But what we're going to do is that we're going to move the rendering of the content, right? We're going to move it not here on the server, we're going to move it to the client. Right? The browser is now going to be responsible for rendering the content, and the sequence of events is as follows. From the point of view of the user, it doesn't really matter. I'm asking for a web page, but now the browser is not going to ask for documents that execute on the server. Instead, it's going to ask for HTML templates for JavaScript that is not going to execute on the server. From the server's point of view, the browser is asking for static content, right? So the browser is asking for static content, and the server just gives it the static content uninterpreted. Here's the raw HTML, here's the raw JavaScript. You do with it whatever you want. Right? From the server's point of view, this is static. From the browser's point of view, when it downloads, the JavaScript that it downloads, right, whether it's React, Angular, Vue, jQuery, is going to cause the execution of that content, right, that comes here that is static. It's going to make it render dynamically, right, and then provide the content to the actor. Make sense, right? So what shifted here is the rendering. Who's responsible for the rendering, right? Instead of rendering on the server, it's going to be rendered on the client. The server still plays an important role, right? The client here, even though it can render dynamic content, it doesn't have data, right? The only place that it can have data is to go and fetch that data to some server. So it's going to have to, a lot of these communication is going to go back and forth, right? The client's going to go back to the server. Hey, server, I need data, right? And the server says, okay, well, what do you need? Well, it needs a list of courses. Give me a list of courses. And the server will do some database access, whatnot, right? It's going to come back with an array of JSON objects, right? It's going to come back as a string, and the browser will parse that JSON object, right? And as it iterates over each object, it will add a DOM element, right? Either a table row or a div or whatnot, and it'll render dynamically the content. Make sense? So the role, the responsibility of rendering has shifted, but the data access, right, and the controllers and data and storage and state management is still in the server. Okay, so yeah, this technique of rendering here is we're going to refer to as the single page application technique, right? Where usually what happens is that only the initial page gets downloaded, the index.html, right? And then we dynamically render in there. Okay? We render in this one single page, right? And we remove content, we add content, we give the illusion of navigation, right, by dynamically flipping between various templates, right, and then filling in the content dynamically, right, as opposed to on the server side, when you navigate, you are asking for a brand new page that has to dynamically render here, and then we show you that dynamic that finished static content, right? So you're throwing away the old page, and now you're rendering a brand new page in its place. And usually that experience looks like drop the page and then refresh the entire page. Very inefficient. An example that always comes to mind on how to compare these two strategies is when I think of MapQuest. Anybody remember MapQuest? Right, in MapQuest, it used to be, maybe not now, but it used to be that it renders the map, and it had buttons that you could click, so you can pan right, pan left, zoom in, zoom out, right? But the implementation was that I clicked the button, right? The whole page was thrown away. It went out to the server, asked for a brand new page, and then it rendered it brand new with a new map, right? Whether it was pan to a little bit to the right, pan to a little bit to the left, or zoomed in or zoomed out. So it worked fine. It worked perfectly. The use case was perfectly implemented. Now, skip a little bit, a couple of years later, the implementation of Google Maps, right? Google Maps doesn't work that way. It uses the single page application strategy, meaning it renders the first map, right? The first page is rendered with an initial default map location based on your location, maybe. But then the page is never thrown away, okay? Instead, it gives you a user interface that allows you to grab the image, maybe jiggle a little bit, and maybe flick it, right? And as you flick it, right, the page doesn't change. And behind the scenes, it's going out to the server, hitting the server, and asking for new images, right, to fill in the empty spaces, right, and giving you the illusion of animating the whole content. Completely different experience, right, where you don't re-render you don't throw away the page and re-render it brand new. Instead, you go fetch new content, and then you strategically fill in the pieces that you need, giving you the illusion of interaction. Same thing with zooming in and zooming out, right? You go out in the behind the scenes and go fetch new content. So most applications today use this strategy, right? Your Facebooks, your Twitters, your Netflix use this single page application strategy, right? They load one big empty index page, and then they go fetch content and they strategically render it dynamically on the browser. Make sense? Web application development, the same skills that we might use in developing any other application. Best practices. We're gonna be all throughout the semester. We're going to be introducing lots and lots of best practices. What is the data, the folder structure, the naming conventions. How do you break out large applications so that typically is for multiple users to collaborate together. Okay, if you're just your own, just you, a lot of these best practices are an overkill. Maybe you won't go as far as breaking it out the way we're going to. So maybe on the assignment at first, it might look like, why are we doing this? Why are we breaking it this way, right? But again, these are all meant to be, large applications where lots of folks are working together, right? And you break it out so you understand what's running on the server, what's running on the client, and to best be collaborate better. Okay.